Hello all, welcome to the video lecture series for the subject operating system. Now I am going to explain you all about a classical problem of synchronization using semaphore. Right, basically I was teaching you all about a semaphore technique with three different aspects, that is signal and wait with semaphore values. Here the same procedure has been adopted for the bounded buffer problem with this producer and consumer technique. Right, basically there are two processes running, say for example, namely producer and consumer, where an operating system on this particular buffer. Right, the producer is tries to insert a data into an empty slot of this buffer, and consumer is tries to remove the data from a filled slot in this particular buffer. So this is the procedure. Let's see, when this buffer, it is full, it will be consumed. When it is empty, it will be filled by this particular producer. Right, let's see, there is a buffer of n slot, and each slot is capable of storing 1 unit of data. So in this particular buffer, which is actually operated, right, let's see how this particular process has been adopted. This one line story is, there is a bounded buffer problem when this producer to load a data, when this consumer to remove a data. So this is a question mark here. When to produce a data, there is an empty slot. When to consume a data, when the slot is full. So how does this particular process is happening? Based on this, we are going to explain you about, I am going to explain you about how the semaphore is actually helping in this particular bounded buffer problem. Let's see, for example, we have mutex, empty and full. Mutex in the sense, that is basically it is mutual and exclusion. MUT stands for mutual, EX stands for exclusion. It is either to acquire or else to release. Right. What is basically this empty is, initially the value is number of slots in buffer. Right, that is an empty procedure. Full in the sense, initially the value is 0. Let's see how this producer and consumer is actually working based on the empty slots. Right, now you can check this. Producer when it is tried to produce, and consumer when it tries to consume. I'll start with this producer now. Do wait in the sense, I'm going to test and I'm going to acquire. Right, this is a wait, the function which is used in this particular semaphore, which is to acquire. Right, so here the wait is going to check the empty slots inside. Right, what this particular producer will do is, it will wait until this empty is greater than 0. The empty is 0 in the sense, that is all the slots has been filled, so producer cannot produce it. Right, so empty is actually greater than 0 in the sense, say for example, assume that how many slots are here, 1 2 3 4 and 5. Right, 5 slots is there. Now I am going to check that if empty is 0, empty is 0 in the sense no slots is actually empty. So empty is greater than 0 in the sense, say for example 5 is greater than 0 in the sense, how many slots are empty? 5 slots are empty. So it will wait until the empty is greater than 0. If it is 1, it can produce. If it is 2, it can produce. 3, it can produce. 4, it can produce. 5, it can produce. That means the empty slot should be greater than 0. Only then the producer can produce. Let's see how it is produced. If it is finding that is empty is greater than 0, it will call this wait and mutex, that is mutual exclusion, to acquire. Mutex in the sense what? I am going to acquire and I am going to use the same mutex to release. If I am finding the empty slot is greater than 0, I am going to acquire, that is by using this particular thing. Acquire lock has been acquired. Now what this producer will do, it will keep on find the empty slots and it will fill the empty slots. Right, after filling the empty slots, no more slots has been left empty to fill. So what it will do, it will call the signal. Now signal in the sense, it is going to release. Right, so I am going to release. Wait is to acquire, signal is to release. I am going to use the signal which is used in the semaphore technique. I am going to release the lock. When I am going to release the lock, I am going to check the signal that is full. See here, this slot has been full. Now I am going to increment the value of full. initially the value is, say for example 5. I am going to increment the value of full now. How? When I am going to increment the value of full, what happens? Full is equal to 5. That means finally I am going to fill all this empty slot. I am going to fill all this empty slot, and when I am getting out, that is producer is getting out of that critical section, it is setting the value full is equal to 5. The condition is true, this keep on executes, right? So the producer sets the value is equal to full. Now let's see what the consumer is doing here. Right, now consumer is calling this wait. Wait is to acquire, as we all know that wait is to acquire, signal is to release. Now wait full, we are going to call the full. The value of the initial value of this full is initially it is set to 0. Now what is the value of full here? It is 5. You can check it here, it is 5. When the consumer left this particular critical section, it set the value of value of this particular slot, that is buffer slot, is equal to 5. Now this particular consumer will wait until full is greater than 0. Now this particular producer set full is equal to 5, right? So now 5 is greater than 0. When this procedure will execute, it will wait until full is greater than 0. Now it is 5, so it is easy for this consumer to consume a data. Let's check how it consumes. Wait mutex. So I'm going to call this mutex, that is to acquire. I'm going to enter into this particular critical section. So when I am going to acquire, this consumer is going to remove the data from the buffer, that is consuming it, right? So it is going to remove the data from the buffer. Let's see how it removes. Now signal mutex, right? When I have removed everything, that is I have consumed everything inside a buffer, I am going to come out of this particular critical section. So I am going to call this signal. Signal is called, and for that signal is going to release this particular mutual exclusion, that is critical section, right? Now finally I am going to read, this consumer is going to signal the empty. Here you can check that this producer is going to signal the full, but consumer is going to signal the empty. Say for example, consumer is consumed everything inside a buffer. What happens? The slot is empty now. So I am going to call this empty here. So when this particular empty is called, that is signal empty is called, this consumer will increment the value of empty, right? Initially the value of empty is 0, and after that the value of empty will become what? 5 now. Say for example, how many slots are here? Say for example 1 2 3 4 5. Now I need to increase. So after consuming all in this particular buffer, the consumer is going to increment the empty slot. Empty slot will be increased now. Say for example, how does it happen? Now empty is initially full is equal to 5. Now empty is equal to 5. What happens? It finds that it increments all the value one by one, and it is leaving this particular buffer empty is equal to 5. Now after consuming all of this data, it is calling the signal empty, and it increments the value of empty. The empty will reach up to 5, because I have drawn one particular example here. You can check that the size of that particular buffer is 5. So it is leaving the empty slot into 5, so that now the producer can produce the data when the slot is finding that it is empty. Now this consumer is leaving the slot empty, and it is incrementing the value of that particular empty slot as 5. And this condition will be keep on executing when this particular while loop, the condition is true, right? So this is how the producer consumer problem has been solved, right? Thank you.